Welcome to the 22nd session of the Flipped Classroom for AP Calculus. In this section, we're going to talk about word problems of extreme value of functions. That's still in section 3.1. Call it part 2. We're going to do problem 50, and it's a lengthy problem, so you probably should have a calculator with you and some paper so you can pause the video and work out some things as we go on the slide. The first part of the problem says to locate point A on the drawing so the total length of guy wire is a minimum. Okay, so basically what you have here is you have two towers. You have a 50-foot tower and a 30-foot tower that are being supported by two guy lines, guy wires, guy lines, which are represented by the dotted or dashed line on the drawing. Where the two wires come together on the horizontal line, that is point A. Okay, and so you need to find out what is the total length of guy wire that would be a minimum by positioning point A somewhere between 0, which we'll say that is right under the 50-foot tower, and 150, which is under the 30-foot tower. Okay? So we need to come up with two equations. You see you have two right triangles there. So using Pythagorean theorem, I get the equation for the length of guy wire 1 to be the square root of 2500, which is 50 squared, plus x squared. And the length of guy wire 2 I get to be the square root of 150 minus x, quantity squared, plus 900, which would be 30 squared. You follow? So GW1 is the square root of 2500 plus x squared. GW2 is the square root of quantity 150 minus x squared plus 900. The total length is the sum of those two equations. Okay, and so I call the total length T here, and it's represented by the equation that you see there. T equals the square root, yada, yada, yada. Okay. Now, to find the minimum or maximum, remember, we need to take the first derivative and set it equal to 0 to find a critical number. We also need to check the endpoints, which are, in this case, 0 and 150. So I take the derivative of t prime, and you get a complicated equation, which is represented on the screen here as 2x over 2 square root of 2500 plus x squared plus 2x minus 300 over 2 square root 22,500 minus 300x plus x squared. I got that by just expanding the binomial above 2500, 150 minus x quantity squared. That's what you get when you expand that binomial, plus 900. Okay? Now obviously some things can be canceled, like the 2's here. The next slide, you need to do this work on a sheet of paper. The next slide is going to show you what we arrive at as an answer for x, making this derivative equal to 0. So I just copy and pasted what was on the previous slide here above, and the way you would solve this equation is I set it equal to 0, okay? And I get 2x over 2 square root of 2500 plus x squared equals 2. I factored out, 2 times the quantity 150 minus x over 2 square root of that binomial expanded plus 900. I solve for x. Notice this is really a proportion, two ratios that are equal to one another, by squaring both sides. Do this on a piece of paper, and then once I've squared both sides, I cross multiply and then gather all the terms to one side, set it equal to 0, and use a quadratic formula. When I use quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, I come up with two solutions. One doesn't make sense because the value of x is not between 0 and 150. The other, however, is x equals 93.75. You should see if you can solve this equation and get the same value for x at this time. To be sure that this value is the minimum, I evaluate the total length equation, t equals the square root of 2500 plus x squared plus the square root of the quantity 150 minus x squared plus 900 at its endpoints 0 and 150. In other words, let's say that x is 0, we're right underneath one tower, or x is 150, you're right on point A would be right underneath the other tower, and the critical number where point A would be located at 93.75. I'm sorry, it should not be 25 there. That's a typo. Okay, notice here the x value of 0, the function value is 202.97. You should check this out using the equation above. That would be an endpoint. At 93.75, the function value is 170.00. That is our critical number. And the other endpoint, 150, the function value is 188.11. The numbers in red mean that that is the least value of the function. Therefore, 93.75 is our critical number. And that is the total minimum length of guy wire that you would need in this problem. The second part of the problem, part B, says show that regardless of what x is, the total length of guy wire is minimized when theta 1 equals theta 2. Notice on the drawing I've denoted what theta 1 is and theta 2. Okay, if these two angles are equal, then their tangents should be equal. Okay, so what we're trying to show is that regardless of whatever x is, meaning where your point A is, the minimum length occurs when the angles are equal. So the way I did this is I said, okay, the tangent of theta 1 would simply be the opposite side, 50, over the adjacent side, x. The tangent of theta 2 would be the opposite side, 30, over the adjacent side, 150 minus x. If these angles are equal, their tangents should be equal. That's where I came up with the proportion that you see as the last line of this slide. Okay? Now notice, what we found out before using calculus, the derivative told us that 93.75 is the magic point for A. That's what x should equal. So hopefully when I solve this proportion, I should get 93.75, meaning my assumption that the angles must be equal to produce the minimum is true. And lo and behold, when you do solve this, you can solve this on a sheet of paper. You get x equals 93.75. I believe it's something like 7,500 equals 80x. When you divide that by 80, you get 93.75. Therefore, I've shown that it doesn't really matter what x is. If I set the angles equal, that will provide the minimum amount of guide wire, which is kind of cool. What I'd like you to do for practice problems, pages 253, numbers 47 through 56. I see I have 253 twice there. It's actually 252 to 253, I believe. Thank you and have a good evening.